shorter lecture. Should be roughly half an hour. And then I'll hang out for the rest of the time, and I'll have some time to answer questions, kind of like a very abbreviated office hours. So we'll get into the content and get through that. I assume like most of you will appreciate a shorter lecture today. Some of you are stressed about a big deadline tonight, so that'll be fine. Even if you're not, if you're done, it's just a little bit of a break. So any questions before we get into this, before we do some content on JSON? Okay, let's do this. So the lecture question today, I have a class that I'm providing for you with just really no functionality, but in two variables that it's going to take in its constructor and store them as state variables, a list of strings for an inventory, and then the amount of cash in a register for a store object. So we have this class. We would have functionality. We're not going to worry about simulating the store for this question. But functionality we do want from this that you'll write is a way to convert a store object into a JSON object and taking a JSON string and populating the state variables with the values from that JSON string. And the JSON string will be an object with the keys matching the names of the state variables, and the values matching the values of those state variables with the appropriate JSON types. This is what we want to accomplish today. So let's talk about JSON a little bit. This is a reminder from 115. We talked about JSON in 115. So just a quick flashback. JSON had 6 types, and we used these types to be able to represent very complex data structures. JSON is a very versatile, very elegant data way of representing data. With just these 6 types, we can represent all kinds of different information. We can have very complex data that we store with just these 6 values, with just strings, numbers, which can be ints or doubles, booleans, arrays, which are sequential data structures, objects, which are key value pairs, and a null value. So 5 meaningful values, and then meaningful types, and null, just to say that there is nothing in here, just no type, lack of a type. So just these 6 types, we can represent very complex data as compared to CSV, which we started with. So we have this problem where we want to send information to another program that might be written in another language using other libraries. We can't exactly just send, we can't send programming language specific types to that other language. We can't send a Scala int to JavaScript and just have it magically converted into a JavaScript number. The JavaScript just has a number class in it. We can't just send it over there. We can't send it to Python, expect it to represent that as a Python int. They may be different representations. We just can't do that across languages. We can't send the data like that. But we can send strings. Every programming language understands strings. So if we take our data and store it in a big CSV, and then send a CSV to another program, or save that as a file and open it in another program can parse the CSV and read that information. But that was very limiting. We can only store a 2-dimensional array, effectively, of information, and we had to add a little extra syntax if we wanted commas in our text data. We had to surround it with quotes and have a few little extra pieces of logic. With JSON, we don't have those limitations. This is very flexible. We can represent pretty much anything with these 6 values, and send that data as a string across programming languages. So last semester, this was pretty easy. Python and JavaScript, we can handle JSON in both these languages in one slide. It was 4 methods. Python, if we have information in a Python data structure, we do JSON.dumps, which is dump S for string, dump this to a JSON string, or load S. I have a JSON string, convert it into Python data structures. JavaScript, Stringify and Parse did the same thing. I have a JSON value, I want to turn it into a JavaScript value, I want to turn it into a JSON string, just stringify it. Why would you do anything else? I have a JSON string, I need it in JavaScript data types, just parse it. JSON.parse, done. But what about Scala? Scala is kind of a different animal here. So with Scala, say we have a JSON string that we want to parse. We want to add this into convert this to a JSON type. So in Python, we would convert this to a Python dictionary. In JavaScript, we would turn this into a JavaScript object, which is where JSON comes from, JavaScript object notation. So that's a simple one-to-one conversion, easy mapping. But in Scala, when we have strong data types, what type do we parse this as? When we parse this JSON string, which Scala type do we represent it as? Now we can represent this itself as a Scala string, but when we want to actually parse the information and get the useful information out of this, what type do we use? How do we parse this and store it in a variable of some specific type when we have a strongly typed language? Python and JavaScript, we could just mix our types. We could have a list or an array that has multiple different types in it. So that's no big deal, but we can't do that in Scala anymore. And we have a JSON object with our keys, which have to be strings, part of the JSON spec. The keys have to be strings, so no issues there. But the values, we have an integer value here, a JSON number, a string here, an ISS position, which maps to another object, which has strings mapping to strings. So how do we represent this in Scala? And by the way, this information is from the ISS API. It tells you, it's an API you can connect to. It just tells you where the International Space Station is at any given time. So we have, in that API has this specific spec. It will return a JSON object with the keys timestamp success in the ISS, timestamp, what are these keys? Timestamp message in ISS position, and the values will be a number, a string, and an object, and that object will have keys latitude and longitude with values as strings. Don't ask me why they chose strings for the lat long, I'm sure they have a good reason, but strings for the lat longs, not numbers. So we know the format and the structure of this, but what data structure do we use, or what type do we use to store this information when it's parsed? So let's look at our options here. Well, the message maps to a type string, so maybe we map a string to strings. We know we have an object here, so the map seems intuitive. We want some key value pairing. The keys being strings is intuitive. Okay, JSON, object. The keys have to be strings. It's part of the JSON spec, so a map of strings seems legit. But then what about the values? So message maps to a string, so let's try string. Okay, but how do we represent this as a string? Maybe we could just two-string that. We could probably maybe get away with that and finagle it for this specific application. But what about this object? Do we represent this whole object as a string? Probably not. How about long? Well, that's good for timestamp, but it's not going to get a success or this object. Okay, a map of string to string, that's going to get us this object. We have a map of string to map of string to string. That's fine, but what about timestamp and message? We're overcomplicating those two now. This just never really works here. There's no good mapping of what data structure to use here. There is one that we can use, map of string to any. So every type in Scala extends any. So this is a valid option. Not one that we should use, but this is a valid option. We can have a map of string to any and store all these values in the same data structure. The problem with this, with polymorphism, if we store these values in a variable type any, we only have access to the methods defined in the any class, which is just a couple of methods, toString, dot equals, hash code. Nothing that's really going to give us the functionality that we want out of this information. So we got to look around for other options, but we're feeling good about polymorphism. So we know polymorphism can get us this kind of functionality. What we need is some base class that all 6 JSON types will extend, and then have a map of strings to that base type. If we can have something like that, we can leverage polymorphism and be able to do what we want to do. And of course, that's what we're doing. We're talking about polymorphism here. This is a solid application of polymorphism. So when we want to mix these types, we're going to pull in some polymorphism. We're actually going to use a library for this. We're not going to build our own JSON parsing and all that. It's a bit too much, a bit more than we want to focus on for 116, but we will pull in a library that uses polymorphism to solve this problem, to accomplish this goal. So this play JSON library defines the 6 types that we need, 6 types as Scala types that are going to represent the 6 JSON types. So we have these 6 types, all as classes, and of course, the one that we really want, they all extend JS value. So now when we're parsing these JSON strings, we're parsing them into JS values, and we're working just with the JS value type, even though that JS value type will actually be one of these 6 subtypes. We're going to write all our code generically as JS values, so now we can work with all 6 of these types at the same time. So now we can have our mixed data structures. We could have an array of strings, booleans, and objects. That's fine. We'll just use these JS classes that all extend JS value and have that array be of type JS value or list of type JS value. So now when we revisit our ISS location, the answer becomes clear. We're going to have a map of string to JS value. Those JS values will be number, string, and object, and that object will be from string to string, but we're using the base class, and we're having our data structure code to the base class, which will have the functionality we need, but working with that abstract class JS value instead of worrying about what the specific type is at any given time. So JS value, if we want to go the other way, and we want to write JSON, we're going to convert our Scala types into JS values, and then convert those to JSON strings. And when we're parsing, we're going to parse our JSON string into JS values, and then figure out what specific Scala types we're working with, and then convert to those types. Okay. Any questions to this point? You can ask your questions on Twitch too. Thank you for the reminder. No questions? All right, moving on. Let's see a couple of examples of this. So that's the background on what we're doing, how we're using this. Let's see an example of reading or an example of writing, and see how this library works. So we have this data that we have, and remember we get this from the ISS API. The API has documentation, and it says exactly the format of the JSON string that it's going to send to us. So we can hard code our parser to be able to work with that format specifically. We can rely on the APIs, and we can't always rely on them, but we're going to rely on the API following its own spec, its own documentation, and assume that these keys do exist in there. We can have some error-tolerant code. We can check if this key exists, then do this, else handle the error somehow. We're going to assume that they're following their own spec, which is what I suspect. We won't be able to know exactly why unless they wrote up some explanation. I would suspect when they first created this API, they had these as strings just because, I don't know, somebody decided, maybe those should be strings. But they probably want these to be numbers now. Or maybe, let me word it this way. If they want these to be numbers instead of strings, they can't make that change now. Now that their API is published, and it's out there, and people have written code to parse this exact format, they can't change those to numbers now, because then it breaks everybody's code who uses this API. Because we're going to say, we're going to treat those as strings. This is going to break if they change those to doubles and just change their API overnight. It's going to break anybody's code who's using this API because they're not expecting the proper types, unless they're really error tolerant in that. So let's use this library. So first we're going to import it. This is, we have to download the library first and link it. I'll have a few slides. I'll talk about that a little at the end. But we do have to go to our Maven, our pom.xml, add this to our file, and then run Maven to download this, this new library. So once we do that, we're going to import it. This play JSON library, we're going to have a few bits of functionality that we're going to import from this. Then we're going to call the big method when we're parsing JSON, JSON.parse. Very similar to the JavaScript notation, except there is more work that we have to do after this, after we call JSON.parse. So JSON.parse, this is going to take a JSON string. So assume this is the string that we're sending it in this case. This is going to take a JSON formatted string and return a JS value. Now for this specific application, we know that JS value is going to be a JS object, but we're storing it in a JS value because that's what this method returns, because this method can parse any of the 6 types. So if you have just a number, if we have just the number 8, for example, with the character 8, that's a valid JSON string. It's just a JSON number with a value 8. Valid string. If we valid JSON string. If we have just a regular string, if we have just success, well, that's a JS string. It's valid JSON. If we had an array with a bunch of values, that's valid JSON. If we happen to have an object, and we typically work with objects in 116 or 115, you probably saw mostly JSON strings representing JSON objects, because that just happens to be the most convenient. But we don't know that, so this can't return an object. It's going to return a JS value, and for our purposes, happens to be an object as its actual type. And then we have functionality in the JS value class, which is going to allow us to work with it. Once we know its type, we can work with it as that type and get the information that we want and handle the information that we want from this thing. So I'm going to take parse, this JS value, treat it as a JSON object, a JS object, which gives us this syntax, which admittedly is a little strange syntax at first. But take this JS value, slash, and then a string. That's going to look for a key with that string name and return it as a JS value if it exists. So we're going to look for the value at message. We're going to find message. That's going to be success as a JS value, which is in fact a JS string for this in this application. And then we're going to use this as method. As is going to convert a JS value. It's going to attempt to convert, anyway, a JS value into a Scala type. This is where we can finally make that jump over to Scala. So this as method is going to take a type parameter, just like our data structures do. It's going to attempt to convert this JS value to that Scala type. So I'm going to say this: get the value with the key message and try to convert it to a Scala string. Then I can store it in a variable type string. I can convert timestamp to a long. Timestamp's too big to fit in an int. I can turn my timestamp into a long, store it in a variable type long. And I can start working with these values as Scala values. Now I can work in Scala instead of worrying about the string, instead of worrying about JSON. We get outside of the world of JSON, into the world of Scala, and then it's just regular Scala program after that. We're not worrying about the JSON anymore. This as method is pretty powerful as long as you're using it with Scala, with common Scala types. All these included map long, in any of the anyval values that go on the stack, map, list, quite a few. This library has functionality built in for a lot of those basic Scala classes. So this as method is quite powerful. I can give it a map of string to strings as a type, and it'll try to convert this value to a map of string to strings. And for this, that value is a JSON object where all the values are strings. So it's not going to complain. It's just going to give me that map of string to strings, and I have that lat long in that map. Now I can say, hey, ISS location, give me your value at key latitude, give me your value at key longitude. Now I can have those values, hit them with a 2 double, convert those to doubles, and now I can work with those in the way that we want to in Scala. This as method will not work with your custom types. When you write this store class for the lecture question, it's not going to work with that. You can't do as store. because this library doesn't know about that type. This library isn't quite that sophisticated, not quite that advanced, where it's going to look at all your state variables and convert it into a JSON string, or parse it as a JSON string from a JSON string. It's not quite that powerful. The library does have to know about each type. So in that library, it has code. This is how you handle strings. This is how you handle ints. This is how you handle maps. This is how you handle lists. It has all that code. It won't have your custom types in there. So the as method isn't going to work with your custom types. So there is some limit to the power of this method. Any questions about reading JSON? Yeah.
So parsed, the value parsed, when you were going through there, you went into message and you were like string parse slash. So you assumed that that was going to be an object that you got out of it after you parsed it?
Yes.
Is there?
Yeah, right here. I assume this is a JS object. I'm sorry.
If it wasn't, how would you?
My code would break. So that is not actually an object. Then this breaks. This falls apart.
Is there a way to read something through JSON if you're not getting an object? Like,
Yes.
Like if you didn't want, you know, yeah.
Yep. Yeah. So like this, after I pull out message, this is a JS value, which is actually a JS string, and at that point, we usually just want to convert it to a string, so we can hit the as string on that one. At this point, this value is a JS number, and we're converting it to a long right away. So we'll know the format of that number. If we're expecting an integer value, or if we're expecting a floating point value, we convert it to the proper type. But this all depends on us knowing the format of the data we're getting. So that's why I'm saying we have to look at the spec for this API, and we have to know exactly what format they're going to give us the information in. Because we are making assumptions in our code. We assume parse is going to be an object. We assume parse at message is going to be a string. We assume the timestamp is going to be a long. We assume all these things. So if they're not following if we're not following their documentation, or they're not following their documentation, our code breaks. This falls apart.
And then the slash is only for if it happens to be an object.
Yeah, slashes for if it happens to be an object, or an array. You can do like /0 and get the first value, the value index 0. It uses that same notation. Any other questions? Let's write some JSON. So let's do that whole process completely in reverse and see how to write some JSON now. So writing JSON, assume we get the information. We have some method that takes those values from this string, where location, I don't show it on this slide, but I have an object named location with two state variables as doubles, named latitude and longitude. So I have these three values as Scala types, and I want to convert them to JSON strings. How do we do this operation in reverse? And our best friend throughout this whole process is going to be JSON from the library, imported from the library, JSON.toJSON. This is going to do most of our converting to JSON strings. JSON.toJSON is going to take a Scala type. Again, this just like the as method, this type has to be a known Scala type. And when I say known, I mean known to the library, and the library has to have code in it that handles this specific type. So you can't say JSON.toJSON, some custom type. I couldn't do just location directly. I can't say JSON.toJSON of location, because the library doesn't know about my location class. This is the class I wrote to store the lat long. So we can't do that, but we can use this with any of the known Scala types that are known to the library and that are coded in the library. So I'm going to convert, I'm going to call it to JSON, and what that does is take a Scala type and converts it to a JS value, if it can. If it can't, we're out of luck. But if it can, it's going to convert those to JS values. And JS values are what we want, because we can convert JS values to JSON strings, ultimately using this Stringify method. Stringify takes a JS value converts it to a properly formatted JSON string. That's our ultimate goal. So we can make these conversions. I also want to build my object for the latitude and longitude. So I'm going to build this in the format that the API documentation says. I'm going to create a map my lat and long to the lat long. These are doubles, so I'm going to convert them to strings to follow that format exactly, because this format wants those strings. It needs those strings instead of numbers for the lat and long. Just part of the spec. Don't ask me why. I'm sure there's a story behind it. But then once we get all these values, I'm going to throw them in a map of string to JS value, just like we were looking at in the earlier slides. Put those in a map of string to JS value, so I can have a map representing my JSON object with the keys as strings, representing the keys in the JSON object, and then have my mixed types for the values using JS value for those types, for the types of the values. And I have my three JS values that I already converted. I'm just going to throw those in my map with the appropriate keys. Now I have a map of string to JS value containing all the information that I need in the proper formats as JS values. So now we need to convert that entire thing into its own JS value, because we need just one single JS value at the end. So now this JS value is going to be, in fact, a JS object. We're just going to code to the JS value class and leverage that polymorphism. Because Stringify is going to look for a JS value. It doesn't care what actual type it is. It's just going to look for a JS value. And finally, once we have our single JS value representing all of our information, JSON.Stringify, and we got our JSON string. So quite a bit more work than it was in Python and JavaScript, because we have to work in a strongly typed language. But we can still get there. We can still get the same functionality. Just more work for each specific application. Any questions on writing strings, writing JSON? Okay, so we talked about a new library. We talked about this JSON play library. We don't have that. It's not just going to come packaged with Scala. We don't have it in our programs right when we create a new project. So we're going to have to use Maven to get it. We don't have to use Maven. I'll backtrack a little bit. We're using Maven in this class, though. Will you add it to our Maven POM file, and then Maven's going to read the POM and download that library. So right now we have this as our POM file, unless of course you can just grab the POM from the examples repo. But if this was our entire POM file, this is all you've needed for the lecture questions so far. We need to expand this POM file to have that extra dependency in it. So we have to find our dependency and add it to this POM file. To do that, we would go to a site called Maven Repository, which is a site that hosts a significant number of libraries that we can download that people have shared with the internet. We can use these libraries in our code. So if we go to this site, we can see all kinds of libraries. And if you don't just take the examples repo POM file, what you would do is say, okay, what was that library Jesse was talking about in lecture? It was the JSON play library. Find this library, and then choose one of the compiled versions of this library that match your Scala version. These Scala versions do have to match. It's the reason we're using 2.12 is for library compatibility. Find a 2.12 version. I'll just grab the latest version here. And it gives me that dependency. It even doesn't make you Control-C. You just click it and it copies to your clipboard immediately. You paste that in your pom.xml, and now you have that library in your code. I highly recommend. Oh, it's so much fun. I don't know. But anyway, just looking around the Maven repository, and just look for libraries that do anything you can really think of. This Maven repository has 16.4 million libraries in it. If you can think of something, there's probably a library that at least attempts to solve that thing. If anybody want to try something? Is there something that you'd want a program to do? Crash. Firebase crash, crash shell. A bunch of sprites. And, what was that?
60.4 million. Are those all Java-based libraries?
They're compiled. They're all Java bytecode. So the source code might be in Java, Scala, or any other language that compiles the Java bytecode, but the libraries will all be Java bytecode, compiled code. So they'll all work in your Java programs, or your Scala programs, or your Kotlin programs. There's several other languages that compile the Java bytecode. They'll work in all those programs. Any software written in those languages. Hey, look at that. Maybe Android. I don't know what these are. Who's the author here? It's fairly recent. 2018 for this one. There's somebody's building for a class. Look into that. I was hoping they have an author on that. See who's building those things. All right, any questions on this? Okay. Well, in the slides, we're back to the lecture questions, so we're done with that. I'll hang around to the end of the time and answer any questions. So, if you have questions for me. Other than that, good luck. Have a good weekend.